Looks like it's time to get started then. Thanks everyone for coming. So, yes, I'm good. Yeah. For those of you who weren't here earlier, there was a bit of a scheduling debacle and some jaundice, but we don't have to go over that. Anyway. So, yeah, I'm Dakota Clark. I'm a product expert at pdq.com, and today we're going to be talking a little bit about a different format of logging than you all might be used to. So usually traditional logging, you can go ahead and output something to the console, which is useful in an interactive scenario, or if you have something that captures the output of the PowerShell window. Beyond that, you can write to a file that has a bit more of a persistence to it. It'll stay on the file system as long as it's not deleted or overwritten. You can also write to a file share, which is a bit more of a central location. So if you need to go ahead and access something from a bunch of different places, you can have one place to put it. Also something like a syslog server, if you want to go ahead and send that off from one application to that. The thing is that these are kind of a pain at cloud scale. In order to do these things in Azure, it's kind of hard and not necessarily easy to go ahead and maintain. So there's something called Application Performance Management, or APM. This is something that you'll commonly see developers use to go ahead and track the performance and the different actions that their code is taking as it is executed. So to give you a comparison with traditional systems monitoring, something we're all used to, and then code monitoring, which is what we're discussing today, is that systems monitoring is outside in. So that means you ask Windows for something. Hey, how much CPU is being used? And then it returns some sort of value or other sort of object to you. Code monitoring is inside out. You're the one who gets to determine when something is sent, at what point some metric is logged, at what point some event is tracked. In addition, you are limited to the APIs exposed by the developer of whatever systems you're monitoring. On the flip side, you're the developer. You get to pick, which is a big part there. And then, of course, you're limited to the metrics exposed by the API. You might know that, hey, there's something that can be tracked but isn't being tracked. That sure would be nice. Well, back to it again. You get to go ahead and just add that in there if you need to. So specifically what we're referring to here is Application Insights. This is the Azure solution, though the concepts talked about here can be used by anything. If you have Datadog, if you have Raygun, Sentry.io, any of those things, these can go ahead and be used. As long as it has a .NET SDK and PowerShell is able to execute those things within it, you're good to go. So Application Insights, as I said, it's APM, it can be used by any .NET language, and that's both in script and binary modules. So you can go ahead and have some sort of cross-compatibility there between the two different types, whether you're writing it in C#, F#, or PowerShell itself. And you can go ahead and collect errors, execution time, and track other events as they occur. You can also build dashboards to visualize those different metrics that you're tracking. All right, so that's pretty easy. That's most of the slides there done. We'll go ahead and jump into the demo of all of this. Pull up VS Code. All right, so first off, you're going to need this dynamic link library. You can go ahead and grab that off of NuGet here. Specifically what you want is the Microsoft.Application Insights NuGet file. You will go ahead and download the package, and then once you have downloaded that package, you can extract it with 7-zip. In this case, we have that file right there. Not much to be seen because it's a binary file. And that's the nupkeg there, which again is another binary file. Once you have that extracted and you've pulled it out, which, you know, we'll go ahead and go over that right now. I think I have 7-zip on here. Code. Nupkeg. No, I don't have 7-zip. Sorry, guys. But yeah, essentially when you open that up, it's going to give you a few different levels of what you can pick. You will have the .NET Framework version, the .NET Standard, and the .NET Core. I recommend grabbing the .NET Standard version of the Dynamic Link Library because that will work pretty much wherever .NET is, whether you're running on something that only has traditional .NET Framework or is running .NET Core. This will work for both of it. Anyway, let's go ahead and fire that off. It's nothing too exciting there. We went ahead and pulled that in, but what we will do is we're going to instantiate a telemetry client. I just called it TC here for short. The next step would be to go ahead and then give it the instrumentation key. You won't have this until you spin up an Application Insights project in Azure. Give me a moment here. It seems I've seen a lot of places it's necessary to go ahead and reconnect to the Wi-Fi when you're on the conference Wi-Fi here. So I'll reload this and we'll pull it in here and I'll show you where you can find this key. If I'm still connected, let's see here. You pulled something? Yes. So it's just being slow. Yeah, well, I'm also impatient, so we'll go ahead and see if we can open it up in another tab. Please. There we go, that's a bit better. So I'll go over here and do that type. Go to my project here. Wait for it to loading. There we go. Very simple to find. It's right there when you first find it. And in case you're feeling even more lazy, you can click right there, and that'll copy that to your clipboard. So once you have that key, you can go ahead and assign it. You'll fire it off, and now you have a full-fledged telemetry client. Woo! But you probably want to go ahead and do a few things with it first. So in this case, we're going to go ahead and fire off an event here. F8, please. There we go. So that will go ahead and track the event. You're limited to 512 characters using this method. And when you're done, an important thing here is that the telemetry client is not synchronous. So that means when you go ahead and fire off some sort of event, it hasn't sent it yet. I can go ahead and force it to send it by triggering this flush. That will take any waiting telemetry that has yet to be sent to Azure and then force it out the pipe, and it'll be cleared, everything will be ready, and you can throw more in there again. So if you need to push it out right away, you'll use that. Otherwise, it's about 5 to 10 minutes, and then it'll send some things out. And that's pretty much the basics of it right there, but we can get a bit more going on. In this case, collecting events, or errors. This one here is the most interesting. So I'll bring it down. So this is a try-catch block. I'm dividing 0 by 0, which will error. But then down here, I'm doing a few interesting things. So because Application Insights won't be able to fully go ahead and pull in a error object as PowerShell sends it out, you'll have to grab the exception. So in case you're not familiar with it here, this $_, when used in a catch block, will be the error as it's occurring, and then you can grab the exception property off of it. If you find some reason to, I haven't, you can go ahead and override the timestamp. By default, this will just go ahead and set the timestamp to when this class is instantiated. And then some additional things here that will really help you out is if you pass in the fully qualified error ID as the problem ID and the script stack trace as the message, when you go to view this in Azure, you will be able to see exactly the line that this error is occurring within your code, which is pretty darn neat, and we'll show that off in a bit here. And in addition, you can set the severity level. Since this is an error, I'm setting it to error. You do have all sorts of different options here. IntelliSense will be nice. You have the options of critical, error, information, verbose, and warning. Generally, this is the only place you'll set that. So once you've gone ahead and built your error object, you can go ahead and pass that into the track exception method there, and then flush it. So give me a moment here, and I'll run this, so this way we can start queuing up that telemetry before we go ahead and show off how to see this in Azure. All right, so that ran. And then another example here. So if you want to go ahead and pass in some additional properties, something that wasn't in up above there that you want to put in, you can do that using this. Now again, because this is using something that isn't quite so nice to PowerShell, you cannot hand it a hash table, you have to hand it a generic dictionary, which I won't be covering how to use these, but it's usually pretty straightforward. You'll set it up like this. You'll provide what the first object is, what the second object is. Everything I'm doing are strings, so I just put that in for both. Go ahead and I put in the name of my property, which in this case is the command name. So that means when this bit of telemetry is captured, it will put in what command was executed to run this. And in addition, I can put in what PS version. So it's another way to go ahead, and if you maybe find a bug or something that only happens on a certain PS version, you can verify it with this by grabbing that information. In addition here, I've just put in some additional stuff just to show you can really put whatever you want in there when you've collected it. It's up to you, and it'll all get gathered. And then this part here is another collection to go ahead and count how many loops are going through in this. Really, there's not much of a reason you'd want this information. It's just a demonstration to show, hey, it's possible and you can use it if needed. So I'll go ahead and run that again. Fire it off. For that to go. All right. We can go check it out. So let's head over to Azure. So you have all this stuff over here. You really don't need to bother with it. What you want is this analytics right here. This will basically get you the raw data of everything you've been sending up. We'll wait for that to load. A little bit there. All right, so specifically, we're going to be looking at the exceptions here. Now, it's pretty simple to pull out the data in this. I'm not going to be covering exactly how to use this query language to its full ability. There is documentation on that, a bit outside the scope of this talk. So to make it simple, we're just going to pull up the exceptions, and we will run that. What that will do is return everything relating to exceptions that instrumentation key has associated with it, anything you've sent off to your telemetry information. So if we expand here, we can see the timestamp. In this case, the problem ID, that was what we specified. I'll head back up. Right here, that fully qualified error ID got set there. In addition to the type, it'll automatically pull that from the exception. We attempt to divide by 0. As you can see right there, something ain't gonna happen. Also pulled on other assembly information related with what we're pulling on here automatically. Again, all pulled from the exception object, so you don't have to do any of this yourself. And then right there, that'll show us where that issue occurred. Now, since we're running this interactively from the console, it's just going to be referencing a script block. It's just going to be referencing line 2 because I have some white space. Oops, some white space here. But if you were to go ahead and run this from a module of some sort, it would go ahead and reference exactly where within that the issue is occurring. And a lot of it you can see is somewhat repeated. And a bit lower. It'll also grab, and not necessarily so accurately, I went ahead and ran this from the hotel last night to pre-populate a lot of this data just in case there was some problems sending it. It says it was sent from a city, Clarkston, Washington, which is not correct. Should be Bellevue, but I don't know. That's Azure is the one who gets to pick where it's coming from. All right. So that is the exceptions right there. Any sort of questions on that so far? Anything anyone wants any more clarification on? No? I'll go back. So the timestamp is when the telemetry is added. So to show you, it's this line right here that determines the timestamp of when it's sent. You can override that up here if you want to, but again, I can't really think of a good reason to. All right, actually I want to go back to that. So let's jump over to this metrics example. All right, so tracking a metric is very simple just to do the basic example. It'll take a double value, so in this case, I'm just passing the largest possible value I can to it. We'll run both these. That'll go ahead and send that off. So I have the metric name here. This can be whatever it is. So if you want to go ahead and track maybe how much memory is a system under, anything really that you want to, any sort of numerical value you would use track metric for. And for later, after the summit, when you're looking over the GitHub repo, which I will have a link to at the end of this talk, if you want to see what any of the possible options are right there for the metric level, they're all available. And another interesting one here is, to be honest, I'm kind of abusing this one, but for our purposes it works fine, is to track a page view. Say you want to track when something is used or just something occurs, you can use track page view. So what that will do is go ahead and take the value that you put in there, and then it will just go ahead and increment that in the Azure Application Insights, basically database, we'll say. I honestly don't know what they're using on the other end of that, and don't really have to, because it is another one of those nice platform as a service things. And it'll allow me to keep track of that. So the main use of this that I see is you want to go ahead and track how many times a certain commandlet or something in your module or a certain command is run. You can do that as part of it, which I have an example of a function here to do that. So in this case, in the begin block, because we only really need to track it once, it doesn't need to be tracked every single time if you have a pipeline input, as in the process block would do. I simply just pass in my invocation.myCommand, and that will be the name of the command. So I can go ahead and within a function copy that around anywhere, and that will allow me to go ahead and track how many times is this function run within a module. And then in addition, I have some metric tracking right here. So to show you a bit of a contrived example of how this all works together within a function, load that in. Double. Remind myself of the name of that. Folk metric example. Go ahead and run that. Okay, so all it'll do is just take the objects that I pass to it and spit them out. But while it's doing that, it'll go ahead and track all that metric information and upload it for me to be able to see. So let's go back to Azure and take a look at that. Specifically, custom, excuse me, I forget if this was custom events or custom metrics. Pull that up. No, that is custom metrics. Probably should have been a bit self-evident there, but oh well. So here we go. So in this case, it's tracking each time it goes through how many times the number of objects within the invoke metric example are used. And then I have previously that metric name. I'll scroll back up. So you can see right there, metric name is tracked down inside here. Should have my, I'm just gonna go ahead and click. Trackpad isn't being so kind to me today. So that'll be value count, not. All right. Okay. So another thing you can do with this is use it to go ahead and track slow code. Say, for example, you have some sort of suspicion that a certain part of your code is slow, but maybe when it's only used over so many times or has so many objects running through it and whatnot. So in this case, I have another contrived example. This will go through and increment an array 10,000 times. This is using the, if you're all not familiar, the plus equals incrementation for an array, which is slow. It'll go ahead, create a new array with one additional spot, add it in, and do that over and over again, which is very slow. Over here, I have a faster option, which is using a list. So let's go ahead and we'll run the code so you can see that example. And it'll also display how many total milliseconds it took to run so we can see that. And then right above, it'll go ahead and track that metric. So this one will take a little bit. There we go. So it took 8,560 milliseconds, or about 8.5 seconds to do that 10,000 times. And then we'll head over here and we'll do the list next. This one will go considerably faster for the same amount of work. There we go, done in 346 milliseconds. I'll go ahead and flush that again, and then that will send off the telemetry to the application insights for me to go ahead and review. Let's see, here we go, 5:34, doing okay for time. Now next part I want to go ahead and move off to is showing an example of how to use this within a module. So let's go ahead and scroll up and we'll review all of this. So also as an example here, not everyone is probably going to want to have telemetry included to record information about themselves while they're using your module. So this is an example of how you can give them the option to go ahead and tailor how much telemetry is available. You could just go ahead and force them to use telemetry if you wanted to. So, oops. Let's come up again. So in this case, I have set telemetry option. What this will do is it allows them an option of none or full. Down below here, I'm just saving it out to program data. Where it doesn't matter, you could go ahead and save this along with the module files itself. You could save this within the registry, wherever you want to, just have a persistent place so you can track what the user's preferences are. Then down below I have get telemetry option because everyone wants to make sure that what they've set has actually gone through. So last, I have this invoke example, and we have a verbose string that'll go ahead and tell us, hey, was telemetry ran or not? So give me a moment, and we'll load that up. All right. So now you notice here that when I ran it, it also says, hey, you can set telemetries with the set telemetry option. Because to be honest, this isn't something a lot of people would expect to see in a PowerShell module. I don't know how many of you have used forgetting the name of it, but the VMware module. That'll go ahead and display in a similar way to go ahead and say, hey, if you want to go ahead and adjust the telemetry levels, you'll do that. I'll show you how to do that here. So within my manifest file, I have a script to process. This is something that will execute the first time upon the load of the module. And this one here, very simple. Just going to write a warning message that says, hey, go ahead and set it with this, and you'll see the output that you'll see down below. So moving on, we'll go ahead and get telemetry option. So currently it's set for none. So that means if I go ahead, oops, I think it was just invoke example. Yes. If I run invoke example with verbose, it'll go ahead, example was invoked. Nothing happened because my telemetry option is set for none. No telemetry is recorded there. If I go ahead and turn that to full and run invoke example, you'll see that telemetry ran. So if I head back over to that module file so we can break down and see exactly what's going on here, I have an option that if the telemetry setting is none, is not equal to none, this will be ran, otherwise it will be skipped. Then at the end, it'll go ahead and flush it. Now that flush can be run whether or not there is anything. If there is nothing sitting waiting to be sent off to application insights, nothing will happen. Everything will go ahead and move on. All right. Now the other thing you can do with this information is you can pull it out and use it in Power BI. So if you have some sort of pre-existing Power BI infrastructure or you want to include it as part of some sort of visualization, you can do that here. Now I'm going to grab exceptions for this. I'll run it. And they make it particularly simple here, because all you have to do is click export, and you say you want to export to Power BI as an M query. Go ahead. Well, I won't save that. I'll just open it up directly. I'll blow this up so everyone can see a little bit there. They have the instructions on what you need to do within Power BI to go ahead and pull this data in for use. So simply just get Power BI, and then you go create new data, get data, blank query, advanced data editor, and then you just paste in everything you see outside of these comments. Head over there. So get data, blank query. Wait for that to open. go to View, Advanced Editor, go ahead and clear out what's there, paste in what we have, go ahead and click Done. It'll reach out to the API endpoint and pull that information in. Now, the first time you do this, it will go ahead and prompt you for credentials. It'll ask you whether you want to use basic credentials, Windows credentials. What you'll want to use for this is the organizational credentials option. Once you select that, you'll go through the standard workflow that I'm sure you've all seen before. We'll say, hey, what's your email? What's your password? If you have 2FA, you'll go through that too. And that'll go ahead and allow you to connect. And now we come back over here to Home and Apply and Close. It'll pull down the information according to that query. Boo. Okay, so at that point, I now have all the different metrics and other information that I saw previously and can use in Power BI. So if you have any sort of BI folks or anyone who can go ahead and use this information and help you write a query, this is a good way to do it if you're using Power BI. So that's pretty much everything there. You can see we have message, method, everything else that you would see within one of these here. Oops. Innermost type, etc., and all whatnot there. Now, sadly, I can't create anything that's super nice. I'm not a Power BI expert. I could go ahead and try and do something, but I'm not too solid at that. I tried and it didn't come out too well. And there's only 6 things, so we don't get to see too much. Yeah. And in addition, just to show a binary example, in case there's anyone here who's curious about it, gone ahead and pulled in a few things. And let me free up some screen real estate there. So within the binary module here, we have the Telemetry Client, very similar to what we had before. I have the invoke example commandlet right there, very similar as before. Except this one here, I took the liberty of not giving them the option of whether or not telemetry is logged. That'll just happen. So in this case, we'll go ahead and if we run this, we'll see something very similar to what we've seen before. So, give me a moment, and I'll have that going. Just gotta wait for it to compile, and it'll give us the output of the library path. Get my cursor there. And select. Let's run that. Hey, telemetry is ran, telemetry was invoked. Cool. Any questions about any of that so far? Anything? No? So in case you don't have any interest in using Power BI, you can also go ahead and create different visualizations here. These visualizations are very similar to the other ones that you may or may not have seen on the home page of Azure, or if you go under one of the different resources that you have. So you can use that too. All right. Close all that off. All right. I think that's pretty much everything. Let me double check. Come back files. Oops, I'll pull that down. Get the demo there. Yeah. So that's pretty much it. Unless anyone has any additional questions or wants any additional examples shown on it. Yeah, go ahead. So within the binary or the script module? Okay, so so the question was, where did I put the application insights file within the script module? So to show you specifically, I'll go ahead. How about we just go ahead and open that up in Explorer? Oops, that's not what I wanted. All right, so within here, I have the DLL file just sitting right alongside. The module manifest will handle telling PowerShell where to load that in within itself right here. I have required assemblies. So because it's in the same path that the manifest, that's the word I'm looking for, because it's in the same path that the manifest is, I don't have to specify any sort of directory. This is just relative to where it exists. So when I go ahead and import and I point to the manifest file, that will be included. Like give you an example, if I go ahead and we'll trash it out, so I can start over fresh here. If I were to go ahead and import the module file itself, it won't pull that in and you'll get errors. There we go. Demo. So there we go, unable to find type. So it's not able to load any of that because the library is not pulled in. If I go ahead and adjust that to point to the manifest, oops, that will work because it does reference that as a required assembly that PowerShell has to process before it can process the module file itself. So that'll clear that up there. Yes. Yeah, so the question was, when you go ahead and give the user the option to go ahead and turn the telemetry on and off, is that something that is handled for you, or is that something you have to code in every time? That is something you have to code in every time in this case. You might be able to go ahead and use a different logging framework. I don't know if everyone saw the PF framework, logging framework. You could go ahead and add a provider into that to handle that kind of information and stuff for you. Because then you would just have the different logging levels. So in a sense, you're still doing it, but it's just you're picking a number within that, which if anyone saw that, check out that YouTube video when it becomes available. Very good. All right, more questions? I think you had one? Yeah, so the question was, if you don't have internet access, what will happen? So in this case, nothing visible. It will attempt in the background, but it will not throw any errors. So as far as your user is concerned, if they're in a lockdown environment, they don't see any difference. There's nothing that will bother them. Any further questions? Anything else? No? In that case, I guess we'll go to the last slide since we're all done. So that's pretty much everything. That is the link that you can go ahead and grab the code, public as of last night. You can go ahead and mess with it. You can go ahead and open up an issue if you have any questions or anything further. But beyond that, that's all. Thank you for attending.